Hello everyone, welcome back to my channel. Today we are diving deep into the fascinating world of integral calculus. So let's get started. Exploring integral calculus. Today we are going to cover these topics. Introduction to integral calculus, the fundamental theorems of calculus, integration techniques, application of integral calculus, improper integrals, conclusion. Introduction to integral calculus. Integral calculus is a branch of mathematics that deals with the evaluation of integration and antiderivatives. It is a fundamental concept in calculus and has numerous applications in fields such as physics, engineering, and economics. At its core, integral calculus allows us to find the area under a curve, which is essential in many real-world scenarios. For example, if we need to calculate the distance traveled by a moving object, we can use integral calculus to find the area under the velocity time graph. Fundamental theorem of calculus. The fundamental theorem of calculus is a concept that lies at the heart of calculus. It establishes a relationship between differentiation and integration, which are the two of the most important operations in calculus. Simply put, the theorem states that the differentiation and integration are in reverse operation of each other. That is, if we differentiate a function and then integrate the result, we get the same function. This may seem like a simple idea, but it has a far-reaching implications in calculus. For example, it allows us to evaluate definite integrals without having to restore the tedious limit calculation. Instead, we can simply find an antiderivative of integrate and evaluate it at the limit of integration. This makes many problems in calculus much easier to solve. Application of integral calculus. Integral calculus has numerous applications in real world, for calculating areas and volumes to determining work done in a given situation in engineering. For example, integral calculus is used to calculate the amount of force required to move an object a certain distance. In physics, it can be used to determine the energy required to lift an object against the gravity. Improper integrals. Improper integrals are integrals that either have an infinite limit of integration or an integrand that becomes unbounded at one or more points within the interval of integration. These type of integrals require a special approach for evaluation. To evaluate improper integrals, we can use a variety of techniques such as limits, comparison test, and convergence test. For example, if the integral has an infinite limit of integration, we can take the limit as the upper bound approaches infinity to determine if the integral converges or diverges. If the integral has an unbound integrand, we can use comparison test to compare it to a known convergent or divergent integral. Conclusion. In conclusion, we have explored the concept of integral calculus and its importance in mathematics and real-life application. We learned about the fundamental theorem of calculus and how it is used to evaluate integrals. Integral calculus is just not a theoretical. It has a numerous practical applications. We explore how it's used in physics, engineering, economics, and even in computer science. You'll see how these mathematical concepts play a crucial role in solving real-world questions. And there you have it, a comprehensive guide to integral calculus. We have covered the basics, the fundamental theorem of calculus, types of integrals, techniques, and application. With dedication and practice, you can become a pro at this fascinating branch of maths. Thank you for joining me in the journey through integral calculus. If you found the video helpful, don't forget to hit the like button. Until next time, keep exploring the world of mathematics. Happy